In this lecture, I'm going to talk about the transform category within the details panel. Now, the details panel has a lot of functionality in it that is specific to the type of actor selected. Those kinds of things will be covered in the lectures on those specific actors, but the transform category is common to all actors, so I will discuss it here. In a previous lecture, I showed you how to transform actors using the translation, rotation, and scaling widgets. But another way to move, rotate, and scale actors is to use the transform category of the details panel. Now, the widgets are useful when placement and scale don't need to be exact and you want to transform things quickly. But for finer precision, or when exact values are needed, you can use the details panel to insert exact values manually. So if I select this chair here, I can change its location along the x-axis by changing this number here. You can either enter the number manually or left click and drag to the left or right to decrease or increase the value. Decreasing the number will make it go in one direction and increasing the number will make it go in the other direction. And then I can do the same for the y and z axes as well. And then same for rotation, you can rotate the actor around each of the three axes. With scale, you can directly enter a multiplier to scale by. So for example, right now the z scale for this chair is 1.0, but if I change it to 0.5, it will make the chair half as tall. But if I change it from 1.0 to 2.0, instead it will double the height of the chair. To the right of the name of the scale property, there is this little lock icon here. Right now it is unlocked, meaning when I adjust one of these numbers, it affects that axis only. But if I want to scale my actor uniformly, I can click on the lock icon to toggle it to locked, and now any change I make to one of the axes will apply to all of them equally. So now if I enter 0.5 for any of the axes, it will make the entire chair half as small while preserving its proportions exactly. And likewise, if I enter 2.0 in any of the axes, it will make the entire chair twice as large. Alright, so unless they are already set to their default values, each property will have an arrow icon to its right. Clicking this icon will reset that property to its default value, which for location and rotation is all zeros, and for scale is all ones. So what happens if you have multiple actors selected? In this scenario, any values that happen to be common to all the actors selected will be displayed. But in all other cases, you will see the text multiple values displayed in the box instead. You can enter a value in the box, and it will apply to all actors selected. Alright, so now I'm going to discuss the difference between transforming relative to an actor's parent and transforming relative to the world. By clicking on the labels, you can change the location, rotation, or scale type to either relative or world. So far, all the actors we've worked with have had the world itself as its parent. So in those cases, there is no difference between setting this to relative or world. But let me show you an example that will make the difference apparent. In Unreal, actors can have parent actors and or child actors. I'll discuss this concept in more detail in another lecture, but for now, just know that I'm going to create this cone here to be the child of this chair. Put another way, this chair is the parent of this cone. So now, if I select this cone with this type as relative, and I set the coordinates to 0, 0, 0, the cone will be located directly in the center of its parent. But if I change the location type to world, the cone will now be located at the center of the world instead of at the center of its parent. Okay, so now I'm going to discuss the concept of mobility. Mobility is a setting that applies mainly to static mesh actors and light actors. The mobility property has three options: static, stationary, and movable. Static means that the actor will remain stationary the entire time, while movable means that it is possible for the actor's location to change. To clarify, the static in static mesh refers to the fact that the mesh doesn't have any moving parts relative to itself, while the static mobility setting means that the actor's location will never change. Going back to when we tried out the first-person shooter template, those cubes in the level were static meshes, but their mobility was movable because we were able to shoot them and move them about the level. If I changed one of the cube's mobility to static, it wouldn't move at all when I shoot it, even with physics turned on. The third option, stationary, is used for actors that don't move, but have other properties that may change during gameplay, such as a light whose color or intensity may change. So what's the point of the mobility setting? Why not just make all actors movable, even if they are just meant to be decorative? The answer is that movable actors require more processing power than static actors because of things like light and shadow rendering. If an actor is static, the engine can predetermine how these things should look. So you should always make an actor static if you can, and only increase the mobility if you need it. And that will conclude the lecture on the transform category of the details panel.